themselves a Chicago. So I didn't happen to have this on my slide. I put it there while we were talking. See if I can. I'm trying to get it to go. Do you see just the presentation or, okay. I don't usually go like this because I like seeing in advance, so we'll all be surprised together. Some of these slides are actually the same that I presented last year, actually in October, when I was talking about the Epic Homes study platform. And now this should say and data. So I won't spend as much time as I did before, but the theory of change that underlies what we were trying to do with the Epic Homes study was to understand how homes can be solutions to health problems through implementation of energy efficiency activities. So what you see in green are things that represent problems that may or may not be associated with living in your home. These aren't always problems, but they're all problems that you might encounter in your home, and some of which can be addressed directly or indirectly through energy efficiency measures that then might lead to improved health and welfare. So I'm not going to spend a lot of time on that or these green and yellow domains. We were interested in research questions around indoor air quality, about how households make decisions to engage in energy efficiency upgrades, and then how they experience getting information about their home. So I'm going to be focused on the indoor environmental quality data. I think, Tammy, that's what we have talked about. So my hope is this is, I guess, meant to share and maybe pick up where I left off last time, share more in detail what kind of data we gathered. And in particular, I'm focused in terms of what I'm sharing. I'm focused on sharing data and its analysis that related to wanting to understand to what extent different locations in the home were similar or different to one another, and mostly focused on similarity and difference for a specific pollutant. So I'm not presenting things like how correlated were TVOC concentrations and indoor CO2 concentrations, though that's an interesting question. But this is more about, do rooms and places in the home follow similar or different patterns from one another? And one question in particular that I'll be driving towards is one that we wanted to answer, is to what extent are bedrooms different and distinct from other parts of the room? And the reason we cared about that is it might represent a unique location for intervention. So if you were going to recommend that a household use an air filter, run a portable air cleaner, is there some rationale to understand where they might put that, or where putting that might have greater or disproportionate impact? So that was motivating our question. I don't need to go through that slide. It would be valuable for you to have in mind what we are talking about when we're talking about these measurements. We're using a commercially available sensor. It's called the Omni. That's the name of the model. The make, no, the model is Aware. The make is Omni. Aware is one commercially, like one commercial player in the indoor air quality sensor space. Their sensor platform measures 7 things: particulate matter. We effectively use that measurement as a PM 2.5 measurement, or super small particles, not ultrafines, although it's probably mostly measuring PM1 or things that are very, very small. Total volatile organic compounds, a TVOC measure sensor, carbon dioxide using near dispersive infrared or NDIR, temperature, relative humidity. And these sensors also measure light and noise. And anyone that's interested in exploring those data and what they have to tell us, I'm open for business. We haven't really plumbed the depths of what we might learn from that. I think there's stuff to be learned there, but we just haven't had the bandwidth. sorry for the oversized picture of the energy monitor. We're not talking about energy data today. But in a given home, we place sensors in a living area, in a kitchen area, in a bedroom, in the garage, and outdoors. That's the green diamonds. And a lot of these homes that we were in 40 homes. The living and kitchen space is followed sort of an open concept. So this is pretty representative of the kind of separation that a bedroom might have from living area and kitchen area. Whoops, I lost my screen. Okay. This, I'm not going to spend a lot of time. If you want to know how much data we have, it's quite a bit. And sorry, I shouldn't be so cavalier. We measured in homes for anywhere from several months to several years, up to 2 years. And the Omni platform collected data every 5 minutes or every minute. We have at least 2 seasons represented in every home. And each row here on this really tiny table represents a home in a given season. And then the coverage that we have. So in terms of hours, we have lots of hours of data, and we were interested in a lot of hourly patterns. So some things that started popping out, if we looked at, these are individual home examples. So example 1 is one home. Example 2 is another home. And then for every hour of the day, which is on the x-axis, we were averaging the concentration that we measured in that room at that hour. So if you look at the top left of this, we're looking at example 1, bedroom PM 2.5. So we're talking about measuring fine particles in a bedroom in one home, but we measured it at least over 2 seasons and possibly over 2 years, depending on which example we're talking about, which home. And so any data point is an average, and it doesn't show any of the confidence intervals here or measure of standard deviation or uncertainty right now. We could get into that, and it varies by home, and it can be interesting, but I'm not going to talk a lot about that. What we were really interested in is, is there a pattern that sort of emerges and is pretty regular in a given room, and then is that pattern similar in other rooms? So if you follow example 1 going down, you're looking at the bedroom pattern, and then you're looking at a living room pattern, then a kitchen pattern, and then an outdoor pattern. And so the hourly and daily patterns indoors looked pretty similar in quite a number of homes. So bedroom, living room, kitchen have approximately 3 local maximum, and they all reach a local minimum between midnight to 5 a.m. Sorry, I didn't say the x-axis here is midnight to midnight on a given day. And then the hourly and daily pattern of indoor PM often look different from the daily pattern of outdoor PM. So the outdoor PM trace down here at the bottom follows a pattern that's more typical, like traffic outdoors. You get a commuting bump between like 6 and 8 a.m. and then another one between like 4 and 8 p.m. So I don't get to see people's faces, but is this making sense? Am I going at the right pace? Okay. So that's one, thank you. I saw your thumbs up. Thanks, Tammy. And I saw a few nodding heads. Like Paul, I think last week, it's like, well, now I'm in a box. in this, I have no idea what people are seeing. So example 2 is just another example that's similar to example 1. So we saw a number of homes that look like each other too. So that the idea that example 1, we might say, looks like the indoor patterns are similar between the bedroom, living room, and kitchen, and they're different from the outdoor hourly pattern. Well, we were able to say that about quite a number of homes. So example 2 is just showing you that in a different home, even if the magnitudes are, in this case, they're kept the same, the y-axes are the same. If you look across the row, they're the same for every type of room. So these are very similar homes. Let's see, sorry, advancing. Okay, now instead of hourly, we also wanted to look at monthly patterns. And this, I think, is in part because my guess was that we might have a different story about homes if we looked at them on the monthly scale, and looking on the monthly scale is more rare in the literature because it's hard to keep sensors in people's homes for this long. And so example 1 and example 2 are showing you that we had some really strong similarities month to month of indoor PM with outdoor PM. So now instead of looking at an hourly average, we're averaging for the whole month 1 data point. And seeing that the indoor pattern and the outdoor patterns look more similar to one another. See, on monthly and yearly scales, yeah, the indoor PM was either very similar in leaky homes or less so in less, and that leaky, less leaky is based on a building energy assessment that was done by another, like not done by us in this case. And we got sort of their output from their blower door test as a measure of air tightness, air changes per hour. Yeah, Paul, I see your hands up.
So Ellison, I'm wondering, are these September and October huge numbers? Are those wildfire influenced?
Yeah, sorry. So I should have said that. This is over 20 for this particular home. Yeah, this is over 2020 or 2021. There were also some more regional or distant wildfires. It represents the fall wildfire season. I don't know, I've been torn about this. This helps me say what I want to say to audiences that wouldn't necessarily be able to see it as well. I would say the trend holds up. Like even if the range in PM is a lot narrower, like there isn't a wildfire season, I would say we still see that monthly and yearly patterns indoors look a lot like monthly and yearly patterns outdoors, or at least a lot more so than when we think about hourly and daily patterns. But this one is from homes that we had in the study from 2020, fall 2020, when there was some major wildfires in the area. For people that might be newer to the group, like the largest in Colorado history, and they were right next to us. That is what's leading to like September, October, November being all above the EPA annual average standard. But even if you look at homes that weren't enrolled at that time, I think the takeaway of like monthly and annual patterns looking similar indoors to outdoors has held up. But yeah, thanks for us. All right, I want to skip this point because I want to get to some other stuff. Okay. So I just picked out specific homes first and talked about hourly and monthly patterns. Now I'm mostly going to be talking about hourly patterns. And now what we were interested in doing after we started seeing like repeatedly similar types of trends, the next question was, well, is there something about homes, like are there some types of homes where the rooms look similar to one another and different from outdoors? And are there other types of homes where they look less similar? And is there something we can learn from that, in particular around bedrooms? So that's kind of the direction I'm going. Hopefully you can also see, I think you could go a lot of different directions. Like we have garage measurements that we also have not explored nearly as deeply as I'd like. So we could ask these questions about, to what extent does room X, is it similar or different from other rooms in the home? But I'm going to mostly be focusing on that question with respect to bedroom air quality. And something I want you to have in mind before you look at a bunch of plots is that I'm really only presenting data for carbon dioxide, particulate matter, and TVOC from here on out. And for the most part, I think I've been able to keep the colors consistent. There's a pinkish hue for carbon dioxide, purplish hue for particulate matter, and bluish hue for TVOC. And then we decided on these bins. They are grounded in as much literature as we can ground them in, but PM 2.5 being the most grounded of bins. So less than 5 micrograms per meter cubed would now be places that even meet the most stringent World Health Organization guideline value, which we're not here to debate, but that value has certainly come up as like, where did it come from? Why is it out there? Then 5 to 10, because 5 to 10 is meaningful for World Health Organization guidelines as a annual average. 10 to 12, because 12 is still the annual average EPA outdoor guideline. And then 35 is the 24-hour annual, not guideline, standard for PM 2.5 outdoors. So that's what informed these bins. We could move them around, you know, or I could see arguments to move them around. CO2, we're trying to interpret the literature that's out there on guidance for ranges of CO2 that are acceptable to less acceptable. So less than 800 would be very low, 800 to 1,000, and then 1,000 to 1,200 kind of span the range of variable guidelines depending on which one you follow, or from ASHRAE or CDC, or if those are all related. And then above 1,200, just give us a sense of homes where the average on an hourly basis is exceeding 1,200. And then TVOC is somewhat similar. We've drawn these boundaries from 200 up to above 2,000, based on disparate but not totally inconsistent guidance in terms of what are meaningful levels for acceptable to less acceptable air quality. So then what you're looking at now is carbon dioxide in pink on the left column of each of these two plots, PM 2.5 in the middle column, and TVOC on the right-hand side, the blue column, in both of these two plots. On the left-hand side, we've averaged all indoor measurements in all homes, which is about 37, I think, for this data set. We have 40 in total, but I think a few homes are not included. So we averaged the concentration of whichever pollutant is represented by the color for that hour of day. So that's why that table before, this is representing something, you know, between, say, a couple hundred to a couple thousand to tens of thousands, 10,000 hours of data across all homes. And then we've plotted it based on what fraction of homes were in a given concentration range. And then each row represents a different season. So I'm going to pick on CO2 because it shows the greatest difference between all indoor versus just bedroom only, which is the right-hand side plot. And let's look at the fall CO2. So this is 3 rows down on both plots on the left-hand side column. So it's pink. And this is where I see visually the biggest difference between bedroom only and all indoor measurements combined, including bedroom. So not just living room and kitchen. We'd get even more contrast, I think, if we left out bedroom from all indoor. But what I want you to hopefully see, I know there's a lot here, maybe now I'm like, bad idea, shouldn't have shown them all. But on the right-hand side plot, which is the bedroom only plot, if you look at CO2, you see more of a U shape where as many as 70%, or sorry, yeah, as many as 30% of homes have concentrations of CO2 averaging 1,200 parts per million per hour for a few hours, from 12 a.m. until about 7 a.m. And then it declines to maybe 5% of homes have those concentrations remain at 1,200 parts per million. And then again, it increases towards the end of the day. And this is pretty consistent with what we'd expect for use case of a bedroom. People go there to sleep. They may close the door, or they may keep the door more closed. And so concentrations of CO2 are going to rise, as that's where people are spending time and they're breathing while they sleep. What I think is pretty marked here is that you see that the fraction of homes where the CO2 concentration is exceeding 1,200 for an extended period of time is taking on a different shape in homes, especially in the fall. We've sort of wondered if that's because in the fall people are cold and maybe more people are closing their doors. we haven't really gotten as far as figuring out how to explain this, but this is the purpose of this kind of plot, was to see visually at first, like, do patterns emerge that look different in the bedroom than they do in the home as an average. And bedrooms stood out a little bit here for CO2. PM 2.5, which is in purple, looks pretty similar across all seasons. There's some differences in magnitude, but in terms of the shape of the pattern of PM 2.5, we see, increases at meal times or traffic times, depending on which is the influencing factor. And it's not that different between bedrooms. We're losing something here by averaging all the data across all the homes. So we're not able to see individual home behaviors by looking at this, but there's one way of looking at patterns in indoor spaces and then calling out individual rooms like the bedroom. Okay, let me see what did I do next? Where am I on time? I can't see the time. Okay, you know that I want to go through all this. We did a lot of correlation analysis. I'm going to kind of skip through that.
It's 1:33, Ellison. So
Okay.
you're doing fine
Okay.
at this point.
Okay. I would be happy to go back and look at correlation plots if we have some time, but I think what I wanted to get to is Ashley Garrett's, as a senior last year, did a thesis, an honors thesis, and took sort of so we had these plots, and these are nice for like graphical exploration of patterns, but it's not really possible to say like, okay, fall CO2 looks different for bedrooms than for all indoor. And I think a lot of people looking at this might also agree, but then it's harder to say, well, is summer CO2 different enough from summer CO2 all indoor? So we're still working out how we might be able to quantify this, but one step in that direction was to take our bedroom and then living and kitchen data for the same pollutant like CO2 and evaluate using a cluster analysis approach that I can dig up the details on, but I don't know that that's as useful for right now, and see if our homes cluster in particular ways. So that's what I'm showing you the results from, is this cluster analysis. I think, I don't even remember the name of it right now, sorry. We worked with Andrew Wilson in stats to make sure we're sort of doing things properly. So he was a really helpful guide on this. But in conducting these cluster analysis, what you see on the left, that's the colorful green and purple, is showing raw distance heat maps by home, which is sort of saying like how we generated the clusters. And what I really want you to see is that we're talking about carbon dioxide here, and we're looking at how bedroom and living room carbon dioxide, or bedroom and kitchen on the right-hand side. If you looked at the relationships between bedroom and living room carbon dioxide across all of our homes, there are two clusters of home types that emerge. There are homes in pink where bedroom and living room carbon dioxide are really highly correlated most of the time across all seasons. And then in blue, those are our homes where bedroom and living room carbon dioxide are not as tightly correlated. Mike, are my words making sense? Because I think for me, this is difficult to actually like talk through. It's very effortful, but I think this has been helping us talk more about what we think is going on, which is that in some homes, all the indoor spaces look a lot like each other when you're looking at them through the lens of an indoor air quality sensor. And then there are some homes that are more divergent. And so there's spatial heterogeneity of indoor air quality in some homes. And it's enough of those homes that it seems worth investigating. So that blue cluster in any of these plots represents sort of the minority in terms of number of homes. But in some cases, it's a very small number, 4 in the top left plot. But I don't know, it's enough that I've thought it's worth pursuing to figure out, well, what is it about those homes that's making those spaces look different from one another? So that's for carbon dioxide. This is the same analysis for particulate matter, where again, blue is representing a cluster where there's more divergence. So for particulate matter, you see on the right-hand side, bedroom to kitchen, there's more homes in that blue group. So there's more homes where bedroom PM is looking different from kitchen PM. And that's probably a good thing because most of the PM we observe is coming from indoors and from cooking in the kitchen. So I mean, to me, this suggests that bedrooms are a bit like protected from kitchen, or more bedrooms are protected from kitchen PM than bedrooms are protected from kitchen CO2, which there's no such thing as kitchen CO2, but like CO2 is more spread out in between bedroom and kitchen. You might want to know, oh, are the same homes showing up in these clusters? I'd like to know that too. I haven't gotten that far. So I don't know. I don't know if we could look at it home by home. Each data point is labeled with its home number, but we just have not gotten that far to look at which homes are showing up in these clusters. So it would be nice to know. I'm probably not going to answer that right now though. And then this is for TVOC, total volatile organic compounds, which if you're less familiar with that measurement, isn't particularly useful for understanding individual sources of volatile organic compounds. It's probably mostly a proxy for people being in the room, and is probably pretty tightly correlated with CO2. We haven't had a chance to investigate that very deeply. If I had to guess, I would guess that many of the homes showing up in the blue groups here for TVOC are similar to the homes showing up in the blue groups for CO2, but I don't know that yet. Okay. So, okay. This tells us which homes are in which cluster. So we did at least get as far as plotting cluster one. So we took our diurnal plots. So this is still midnight to midnight. And now instead of the concentration, we're showing the correlation coefficient between, on this slide, bedroom and living room. So all of these data are showing the correlation strength, Spearman correlation strength between bedroom and living room, carbon dioxide on the left, particulate matter in the middle, TVOC on the right. And we've plotted the correlation coefficient strength as a time of day function. And we've separated it for homes that fell into cluster one versus homes that fell into cluster two for the bedroom living room analysis. So homes in cluster two for carbon dioxide are not necessarily homes that are the same for cluster two in particulate matter or TVOC. That's what I was saying. I could look across these now, but I don't necessarily know that. We just wanted to see, do they actually have different patterns? Like cluster analysis tells us they're different. Like when we go back and replot the strength of the relationship between carbon dioxide in bedroom, carbon dioxide in living room. And what you'll see on the left-hand side is really a lot of high correlation. So a lot of those correlation coefficients are above 0.5 at most times of the day for any of these pollutants, actually. Cluster one, to me, is a cluster of homes where carbon dioxide, particulate matter, and TVOC, you could pick anywhere in that home to measure it, and it'd be pretty well correlated with what a measurement was in another room. Magnitude might differ, but the pattern over a course of a day is going to be pretty tightly correlated. In cluster two homes, the correlation strength is lower and also sometimes is even negative, or like it's weaker and a little bit more volatile, maybe. For me, this was a good verification, like our cluster analysis actually meant something with respect to what we were trying to investigate. This is for bedroom living room, and then this is the same style of structure for plotting, but for bedroom kitchen results. So the clusters are now out of the bedroom kitchen analysis. And let's see, there's a few, like, yeah. Let me see. Okay, yeah, so there. I wanted to leave time for some questions. I think these are somewhat, probably because we haven't fully completed the analysis that I'd like to complete. I'm not really able to like sum it all up. It's not a paper that's published yet. It's in progress. I do think these can be kind of challenging to talk through. We've been working with them for quite a while. I still find it pretty effortful to explain what we're learning, and I've tried, but I'd like to just see if there's some questions or, you know, I don't know. I'm not quite sure how to wrap it up. I can certainly go into more detail on certain plots, but I had not intended to pick up the whole time. I'm going to end the show, so at least that way, if somebody wants to jump around, do a different plot, we can do that too.
Thanks, Ellison.
Mm-hmm.
Yeah, there's a lot here. I'm reluctant for you to end the show, but I'd like to look at people too.
Yeah, well, or just, I mean, I don't mind sharing. I just was thinking if,
I'm making the people bigger now and the PowerPoint's smaller in my Zoom. But, so, okay, I'll kick off with a question. So one of the reasons that we've been thinking in our measurements in having this separated zone, which is usually a bedroom, is because of some of the early work that I saw from you on if a zone is different, it's likely to be the bedroom.
mm-hmm.
And that's not always the case. But is it as simple as some people keep their bedroom doors closed and some don't? Or is it not that simple?
Unfortunately, I don't know that we gathered those explanatory data consistently enough. We didn't ask about doors being closed in our surveys. We asked about exterior doors and window opening. I'd say anecdotally, because we had a lot of revisiting time with homes, we did ask, like, do you tend to keep your bedroom door shut? And some homes where the bedroom looked different, it seemed to be because of that, but it wasn't always that, because sometimes the bedroom was just like far enough away and on a different floor, which I think I don't know, a lot of this work, sometimes it feels like, well, did we need to collect all this data just to find out, like, if you have a bedroom on a different floor far away from the kitchen and you keep the door shut, it's gonna be like a different room. Maybe Paul, you're like, yeah, I could have told you that. Yeah, I think you're getting at my own personal insecurities of what are we adding of value to the literature? Like, there's not a lot of studies that have the length of measurements that we have, and we've been trying to look at it to say, like, what could we learn from these data that haven't been possible to learn from shorter sprints of data collection. And temporal patterns, like daily temporal patterns over different seasons, seems like a worthwhile thing to investigate for the purpose of sharing with others who are interested in, like, how spatially heterogeneous or not are the places that I'm doing work. But I'm not sure we're learning a lot of things we couldn't have known if you're a practitioner who just like went to someone's home and asked them, how far away is your bedroom from your kitchen, and do you keep the door shut?
Well, I'm not trying to make it overly simplistic or say that data.
No, I am though.
I'm not trying to say that data are not valuable, because we know how poor self-reporting can be also, right? And so having that confirmation both tells you if what you thought was true really is true, and then how often it might be true. But yeah. Anyway, I'm going to let other people ask questions. Go ahead.
Well, can I just say I want to say one thing, because I think what plays in my mind is some of the people that I've worked with who work with asthma, families with asthma, and they are like, the home, it could be a problem. And I think I've been curious, like, well, could we get a lot out of just the bedroom? Like, would the bedroom be a good place to go put stuff? And it seemed like from what I've been reading, there hadn't been enough work on it to be able to say like, yep, bedrooms can turn out to be quite different from other parts of the room, for better or for worse. And so they might be a good place of intervention. And this work might sort of bolster that narrative, which people who work in homes might feel like is already known. But
So, a couple of thoughts I have here. One is, I mean, I think the temporal stuff, by hour and by, across seasons, I think is really interesting and definitely is, really a step forward. You could choose to be a little dismissive of some of the spatial things, like, did we need to do all of this in order to be able to say that things are like this? But as somebody who sits in a lot of standards committee meetings about ventilation in residential buildings,
yeah,
people really like to think that everything is a single zone until they would really rather think of things not as a single zone to bolster their arguments that we have to do a bunch of other things that might not be useful. And when all anybody has is an opinion and don't have data, then people yammer on about stuff and it just ends up being big fights. And so I feel like even having data to show that what a lot of people thought was probably true, but we don't have a lot of data to show is true. Sometimes people really need that. And so I think, I mean, I love it. I love this stuff. I think this is really, really helpful. And can really help to answer some important questions or put some arguments down.
to rest. Yeah.
Yeah. And that we spend way too many hours on. So I mean, I think this is all great and all very useful, just in different ways. It doesn't surprise me that bedrooms are different because people do close their doors, and we know that doors can have a big impact on the overall mixing. But yeah, it's what is interesting though is that it's not as different as I think a lot of people would think.
Right.
Even if it's more different than the other spaces, it's not as different as a lot of people would think. And I think that's really that was one of the things that really struck me as you were presenting this.
Yeah.
Does anyone else have questions? I could ask a lot of questions, but I want to offer the opportunity for other people to have questions, especially people who are now in Epic Homes, right? Who are thinking about where to place things. What does this mean to you?
I want to call it, since it's no question at the moment. I think it's tempting to look at this plot and be like, oh, there's a lot of boring time where most homes are just fine. Another way that I look at this plot and what I would love to do but haven't yet is like, is it the same homes that are always in that 95th percentile? Like, there are some homes that all hours of the day, and I trust like, I think we've gone through our data enough to, like, I feel very trusting, maybe not, maybe too trusting, I don't know. Like, PM is above 35 micrograms per meter cubed in a couple percent of homes. I know that's small, but like, if we want to target interventions, I find this very motivational. Like, what could we learn about identifying those homes? Because those homes need something to help them improve. And it pops out a little bit. Will has been on some of the exit interviews. Like, there's been a couple of homes where we've been able to talk explicitly about, like, looks like your bedroom is always above X amount for particulate matter. We think you have a humidifier. That wasn't the case in one home, and maybe it wasn't another, but I think we've been able to use them for good. But I think investigating that 90 to 100 percentile range and seeing if they're the same homes and they have similar type problems, could be interesting. There's something in the chat. Oh,
So just said he had to
yeah.
go. Yeah, I really like this plot. I'm assuming that you screened out smokers. That there are no
Yeah.
smokers in your
Yeah.
sample.
Do we make them? I don't know that we made it ineligible. We did ask about smoking. And the home, and in fact, we didn't get any homes with major smoking. Maybe we screened it out. We might have screened it out. And in another study, we're not screening it out, so that's why I'm pausing at the moment.
Do you think the high CO2, that your explanation of the people are sleeping in there, and so maybe they're just breathing into their space, but is that an issue? Are those levels that are of concern?
Yeah. There are levels that make you sleepy. So, yeah, so this is just categorical, and it just means it's above 1,200. There weren't too many where it was like above 2,000 actually. I think the honest answer is I'm probably a little out of date on what is the cutting edge on CO2 exposure and outcomes of interest. I'll put my personal viewpoint on this is that there's more research on how CO2 is making people sleepy and drowsy and stupider on tests than there should be, given the other types of problems we have in homes. The homes, like, if that's the issue that you're getting to solve in your home, you are a very lucky person. So I held somewhat strong opinions about, yes, I bet it's true. I bet it's true if we did a couple more $1 million NIH randomized controlled trials of reducing CO2 that office work efficiency would increase and maybe cognition would improve a little bit. Maybe there's a rationale for it in schools so that kids could do better. But even so, like, I really feel like it's not the type of problem, given the other problems we have to solve, that's not the one I want to go, the hill I want to die on. Yeah, so my view is like 1,200. Yeah, there's some people now that are saying, oh, 1,200 would be so bad, we really need to mitigate that. I just don't think it's that important. I'm probably gonna look like an idiot in 5 years. Like, I don't know, I probably sound like, I feel too strongly about it to not look like an idiot in the future.
Look like idiots together, Ellison.
Okay, well,
okay.
I don't know, when I think about like pest
sensitive.
management in residential motels that I've been in, I'm like, I don't care if the CO2 were 3,000 every single day in that place. The problem they need is, like, they need a place to cook their food, and they need a place to, like, live that's without bed bugs and pests. Like, those are bigger problems.
That's fair. So I'm gonna let Misa have the last word.
Yeah.
Misa, do you want to put your question forward?
I guess it was actually. Yeah, so me and Jordan were just kind of wondering whether these results had any correlation to like how old a home was, or if there's that data available at all.
Yeah, so we do have age of home, and Kelsey Walker, who Paul worked on those data. Age of home was as kind of followed the literature on this, Misa, in that we tend to, age of home and leakiness do tend to be correlated at national scales. That also showed up in our study, where older homes in this study tended to also be leakier than the newer homes. And so, yes, I would say yes, that's a factor, and probably the leakiness is what matters. The age is a proxy for that leakiness. In Fort Collins, the expectations, there's some exceptions to that because the housing stock that's also in some of the wealthier parts of Fort Collins is getting renovated from the inside out. So the home on paper would be like a 1890s home, but like we joked about like, what's the biological age of your home versus like the real, the built age of your home, or like how, like, I don't know, there are a few people on my team who are older, one of whom had a hip replacement. It's like, my hip's only 5 years old. So like maybe the systems in some of the older homes in Fort Collins are actually pretty young systems. And so maybe we should think about system age of homes. But yeah, these data held up the more common trend of like age and leakiness. The older the home, the leakier it is. I thought it was a cool idea though, because then they thought the ad could be like, does your home need Botox? Like, take your home, down in age by 10 years, give it a weatherization treatment or something like that. That was tossed around a couple of years ago. It was a good question.
Okay, well, I think we need to wrap up. Everyone have a good weekend. Thank you, Ellison, for bringing us into all the data with you and your really challenging analysis. I can see why it's not done yet. But I hope to continue to hear results from you. And even if you don't have the cluster analysis to prove what you sense from all the data that you have, I really encourage you to bring forward ideas about mixing, or how well mixed a home is, what the real problems are, and so on from what you've seen, because I think sometimes we gather a lot of wisdom and insight from what we're observing, and then it takes a really long time to condense it into something that other people will believe, but we'll believe you. So thank you so much for your presentation.
Thanks for the opportunity. Thanks for the questions too.
Thanks, everyone.
Good
See you
weekend.
next week.
Done.
Bye.